Okay, hello guys. Today our topic is about perpendicular lines, okay? So let's move into the first slide about what is the perpendicular line, okay? So here you can find it in the slide, you can find there's a graph, right? That's about perpendicular line. So you can find the red line and the blue lines, maybe L1 and L2, they're perpendicular, okay? So we can set they intersect, and here the angle between the intersect angle is 90 degree, okay? And also we can using this symbol to represent for their perpendicular lines, okay? So here in the two lines, the lines L1 gradient equals to 1, and the second line L2 gradient equals to -1, okay? So we can set here, if one line slope is an upward or positive gradient, another perpendicular line must be slope downward, okay? That is it. That is a perpendicular lines, okay? So here we can also find, maybe you can also draw some other graphs, like you can draw maybe one line's gradient equals to 2 and find another gradient, okay? And after you draw many examples, you can find they obey the laws that two lines gradient m1 times m2 equals to -1, okay? Also, you can sketch the graph like m2 equals to -1 over m1, okay? That is a basic algebraic rules for this, okay? And also, for example, like here, I draw a graph for you. If we have original gradient m1 equals to 2, so we have a flip or change signal for the gradient. That is -1 over 2, okay? Or we can also say here, perpendicular gradient is -1 over 2. And also for this, original gradient is -3 over 4. First flip and then change the sign. You can find positive, a negative signal turns into positive sign, right? And 3 over 4 turns into 4 over 3, right? And then the final answer is 4 over 3. And for 1 over 5, first flip it, becomes 5 over y, right? And then change the sign from positive sign to negative sign. So here it becomes into -5, okay? And the original gradient here is -1, and after we flip and change the sign, it becomes +1, okay? So the perpendicular line or gradient here equals to 1, okay? So we can check them together, like -1 times +1, and 1 over 5 times -5, -3 over 4 times +4 over 3. You can find their gradient product it always equals to -1. So the rule is correct, okay? Okay, and for example, like here, we have a problem. It said, find the equation of the line perpendicular to y equals to 1 over 3x plus 4. Okay, so first we can set, because two lines are perpendicular with each other, so their gradient product equals to -1, right? So we have the gradient times 1 over 3 equals to -1. So we can calculate that the gradient value equals to -3, okay? That is it. And we can set, because gradient is -3, we can write down the new form as y equals to -3x plus c. So we can put 2 and 95 into the lines. It becomes 95 equals to 93 times 2 plus c, right? And finally, c equals to 1, okay? So we can set, finally, the line gradient equals to 93 is -3x, and the intercept is 1, so it's -3x plus 1, okay? So that is a final equation, okay? That is it. And also, another example, we can just use in general form to find another perpendicular lines. For example, like here, we have the line L1 is perpendicular to line L2, right? And here we can find the L1's gradient, its formula is 3x plus 2y equals to 8, right? Okay, 3x plus 2y. And then you can set, maybe here, the line L2 is perpendicular to the line L1 through the origin, right? Okay, so you can just turn the maybe the lines into a new form, okay? So here is, maybe we can write as y equals to first is 2y equals to 8 minus 3x, and then divided by 2 at the same time. It becomes y equals to 4 minus 3 over 2x, right? And then you can set, maybe this is line L1, right? And line L2 is perpendicular to line L1. So the gradient m times -3 over 2 equals to -1, right? And you can find gradient here equals to 2 over 3, right? That is a gradient form, okay? So now you have the gradient, and you can also calculate the c, right? So here is y equals to 2 over 3x plus c. And you can also set, here it passing through the origin, right? So origin point the coordinate of it is 0, 0, right? So we can put 0, 0 into the, so that is 0 times 3 equals to 3, 2 over 3 times 0 plus c. So finally, the z equals to 0, okay? So because that finally the gradient is 2 over 3 and c equals to 0, that is only we have 2 over 3x, right? Okay, that is the equation of line L2, okay? And here's some deliberate practice for you. You can just try to solve them, okay? So if you want to just do it yourself, you can pause the video. And if you want to follow with me, you can keep on going, okay? So let's move into the first problem. Is that what's a perpendicular gradient to a line with m equals to 94? So we can just using the formula, right? The equation said the gradient 1 times the gradient 2 equals to negative 1. So you can find one of the gradient is negative 4. That is 94 times gradient equals to negative 1. So m2 equals to negative 1 over negative 4 equals to 1 over 4, right? That is the formula. And you can find in the second form is that maybe here the lines y equals to 3 over 5x plus 2 and 5x plus 3y equals to 15, right? You can just transfer the second line into a general form, right? So you can find that is y equals to negative maybe 5x plus 15 and then divided by 3 together. That is negative 5 over 3. Here is only 3, right? And you can find negative 5 over 3 times here 3 over 5. The value equals to negative 1, right? So we can say they are perpendicular lines with each other, right? That is the second form. And for the third form, you can say find the equation to the line perpendicular to y equals to negative x plus 6 and passing through 4, 7, right? Okay, so you can just set maybe here, you can put 4, 7 into the lines, right? And that is maybe for 7 equals to negative 4 plus 6. Okay, but here, this is a point on the new graph, new lines, right? So first we can say gradient times the gradient here is negative 1, right? It equals to negative 1 because they are perpendicular lines, and gradient equals to 1. And also, the line passing through 4, 7, you can just using 4, 7 to put into the lines. So y equals to mx plus c. We knew that m equals to 1 already, right? So it's y equals to x plus c. And it also passes through 7, 4, 7. That is 7 equals to 4 plus c, c equals to 3. So here, the gradient is 1, c equals to 3. The line's equation is y equals to x plus 3, right? That is a third equation. And for the last problem is that maybe their line is passing through 1, 2, and 3, 8. Find the equation of the line, right? So first we can just try to write down the equation of line AB, right? So we can just assume that y equals to ms plus c, and then we can put a's coordinate and b's coordinate into the equation, right? That is 2 equals to m plus c, and here 8 equals to 3m plus c. You can just make it become a simpler form. That is here, m equals to 3 and c equals to negative 1, right? So the line AB's equation is y equals to 3x minus 1, right? And we knew that the perpendicular line is perpendicular with line AB, right? So here gradient equals to 3, we have gradient times 3 equals to negative 1. So now we have the gradient equals to negative 1 over 3. So here the equation is y equals to negative 1 over 3x plus c. And now you find it's passing through point A, right? So we can put 1, 2 into it. It becomes 2 equals to negative 1 over 3 times 1 plus c. So finally, c equals to 2 plus 1 over 3 equals to 7 over 3, okay? So finally, the gradient is y equals to negative 1 over 3x, and the intercept is 7 over 3, okay? So that is the equation of the perpendicular line which passing through the point A, okay? Okay, that's all of the lesson. So I hope you can understanding about how to calculate the equations of the new lines, perpendicular lines, what is the relationship between two perpendicular lines gradient, okay? They are very important in IGCSE Mathematics past papers, okay? So after this class, you can also do some other practice for you, and I also offer you some practice in our website, okay? So subscribe me to follow more about this, okay? So see you next day. Bye.